So what we're going to be working on today is relationships between exponentials and logarithms. One thing you're going to want to be able to do is have a certain form. So for example, if I say b to the power of x is equal to y, we also need to know that that means log base b y equals x. So we're going to be going back and forth between these two. All right, so right here we can kind of take a look at that 5. That's the base. 5 squared is 25. All right, but if I wanted to change it to logarithmic form, sorry, I'm going to write log, there's my base, which is 5. I'm going to put 25 equals 2. And here's how you check it. You go around the world. Is 5 squared equal to 25? Just like is b to the power of x equal to your y. So that's how you check your answer, just to make sure. All right. And on this one, we're just going to go around the world. Makes it very easy. 32 to the power of 4/5 is equal to 16. So on this problem, I'm going to write 32 raised to the power of 4/5 equals 16. 32 raised to the power of 4/5 equals 16. I think I might have missaid it, but that's what it's supposed to be. So this is going to be my answer for the first one. This is going to be my answer for the second one. All right, so let's go ahead and type these in now, okay? So we're going to change this. So you can see the log base right there. We're going to put base 5. We're going to type in a 25, and then we're going to put the equal sign, and we got to put the 2. So remember, you check, right? 5 to the power of 2 equals 25, so that one's good. This one we have a base of 32, so I'm going to type in 32. But I got to raise it to a certain power. So what power? I got to raise it to the power of, I got to put that little 4 over 5. And then I got to set it equal to 16. And you're done. All right? Okay. So right here, one thing you're like, what in the world? How am I supposed to do this type of problem? So these are kind of cool tables that you probably would need to write down in your journal. And they're really easy if you understand a certain concept. So we have 2 tables. You will not, it says you will not need a calculator. It's going to be just fine. All right. Now, what I'd like you to do to help you understand this problem, though, all right, what I'd like you to do is go to Desmos with me. So if you have Desmos, you can go there. Let me go ahead and open up Desmos here. All right, because I want you to see something here. Y equals 2 to the power of x, and then I'm going to put the inverse, which is y equals log, so miscellaneous, log base 2 of x. Oh, could I go in there? X, good. Now check this out. These are inverses of each other because they do reflect across y equals x. So these are inverses of each other. Check this out. Look at the table. Remember what inverses happen in a table. So check this out. Are you guys ready? See that has a 0 and a 1 and a 1 and a 2 and a 2 and a 4? Well, the inverse will have the opposite. Look, it's 1 a 0, a 2 a 1, and then I'll put a 4 and a 2. So I'm going to take a screenshot so you can kind of hopefully see right there. There we go. I'm going to take a screenshot. Okay, there we go. So here's what I want you to notice. Look at this table, and this table goes with y equals 2 to the power of x. And look at this table right here, and that goes with y equals log base 2 of x. So if you have a 0, 1, you got a 1, 0. A 1, 2, you got a 2, 1. 2, 4, you got a 4, 2. So here's the good news. We can go back and look at our problem and solve it. Ready? So let's check it out. This has a what? A 2, and we're trying to figure this out. Well, this has a 100 and a 2. This is going to have a 2 and a 100. All right? So that has an 11, right? 11 goes with what number? Well, if this 11 goes with 1.041, then this 11 will go with 1.041 because this logarithm and this logarithm, these right here, they're what's known as inverses of each other. So if you know that they're inverses, it makes this problem really, 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 really easy. So I'm just going to go over here. Oh, hold on. Let's see here. Yeah, relationship between exponents and logarithms. So I'm going to type in 100. Because if this is 100 and a 2, that's a 2 and 100. And then if this is 1.041 and 11, this is 11 and 1.041. That's all you got to do. Okay. Well, if they're inverses of each other, then all we got to do is take some points and make inverses. So it says the 5 points are plotted on the graph of y equals log base b of x. Based on only these 5 points, plot the other 5 points. Let's do it. So if I have a point right here, I got to have a point right there. Right? That's 1, 0. That's 0, 1. If that's 2, 1, I have got to have a what? A 1 and a... Oh. 1 and a 2. Where's my other points? Oh, here we go. Here we go. If I have a 2 and a 1, I've got a 1 and a 2. If I've got a 4 and a 2, I got to have a 2 and a 4. All right, if I have an 8 and a 3, I got to have a 3 and an 8. And if I have a 16 and a 4, I got to have a 4 and all the way up at 16. So now I have everything plotted that they are now inverses of each other. And that's all you got to do. Hope that was helpful. Now what we're going to do is we're going to move on to Intro to Logarithmic or Logarithm Properties. So here's what I need you guys to do right now. I need you guys to make this table in your journal. So make that table in your journal. And then we're going to make this table, all right, except we're going to put numbers so you can kind of see how they work with numbers, not just letters. All right, so go ahead and make that in your table. Make that table in your journal. All right, so what we're going to do is we're going to talk about the product rule to start with, okay? So I'm just going to write it down right here. Log, let's say we had log base 3, all right? And I put a number like, say, 12. What I want you to understand, in the product rule, I can actually break this down into two numbers that multiply together to equal 12. So for example, I could say log base 3, I could put a 6 plus log base 3, 2. So I could do that. I could also break it down differently. I could say log base 3, and I'll put 4, plus log base 3 of 3. Because 4 times 3 is 12, and 6 times 2 is 12. Now here's kind of a cool rule right here. This right here always equals 1. All right. So something you need to know, if I have log base b of b, what is that going to equal? Well, whatever that number is, that will equal that number. So if I have log base 3 of 3, that will equal a 1 because that's the power of 1. And 3 to the power of 1 is equal to 3 to the power of 1. So this right here actually would simplify to log base 3 of 4 plus 1. That's another way of looking at it. But the main thing I want you to get from this is you're looking for two numbers that multiply together to equal this number right here. So that's called the product rule. So the next thing we're going to talk about is what's called the quotient rule. So let's go ahead and do log. Let's do base 7. And let's put a number like, I don't know, let's put 2. All right? All right? Or let's start with a fraction. Yeah, let's start with a fraction. Let's say like 16 over 5. So 16 over 5. All right? So if I have this right here, using the quotient rule, I can break it down. Log base 7 of 16 minus log base 7, 5. These logarithms are equivalent. But here's kind of a cool thing. I'll do what I was about to do. Ready? Log base 7 of 2. So I can basically find any two numbers that divide to equal a 2. So I could break it down and make up whatever I wanted. I could do log base 7, let's say, how about 20? And do log base 7, 10, because is 10 divided by, sorry, is 20 divided by 10 equal to a 2? Absolutely. You could make up your own. So I could do, let's see here, let's do 6, and then if that's a 6, what would this have to be? That would have to be a 3 in order for it to equal a 2, because 6 divided by 3 is 2. All right, so that's called the quotient property. All right, so the quotient rule. All right, the next thing is what's called the power rule. Now, I think the power rule is probably the most important rule of them all because it's going to help us solve when we're trying to solve for exponential functions, and we'll be using logarithms. So here we go. So let's just write down some numbers that go with it. If I say log base 2, and then I put, say, 5 to the power of 3, like that, that could also equal 3 log, all right, 3 log base 2 of 5. So the power property allows you to take that power and move it down in front. That's called the power rule. All right, so let's go ahead and make up another one here. Ready? So let's call this log, and we'll say just base b, and then I will just do 5, and I'll put raise it to the power of x, like that. Well, that would equal, if I take this using the power rule or the power property, if I move that down in front, that would be x log base b of 5. All right? So we will show you the importance of why you want to use this rule. All right? So let's go ahead and take a look at these, do some examples, and see if this works. See how this makes sense. All right? Here we go. All right, so basically they just expanded it. All right, so we have log base 6, and they did 5y, which is the same as 5 times y. So they expanded it to make it log base 6 of 5 plus log base 6 of y. See if they give us some examples. Here, you're condensing it. Multiply those together, you get 10x. That's called the product rule. Let's see if they give us some. Oh, here we go. So let's say it says we need to expand this. So if I wanted to expand this, 3a is the product of 3 times a. So I could say log base 2 of 3, and then I could put plus log base 2 of a, because 3 times a is 3a, and that's it. Ta-da, see, look, I got it right. And if I wanted to condense this, all right, if I want to condense this, I can multiply 2y times 8, which is 16y. So I could condense this because they have the same base. That's a base 5. That's a base 5. I would write log base 5. And then I just do 2y times 8, and I get a total of 16y. And I'm done. Okay, so that's called the product rule. You can either expand or you can condense using the product rule. Now let's look at the quotient rule. If we wanted to expand this, right here, you're going to do a minus 2. So we have log base 7a minus log base 7,2. Now, the product rule, quick little, let's go back, let me show you something. Hopefully this will make a connection. Go back real quick to over here. All right, so just remember, the product rule for exponents is if you have b to the power of m times b to the power of n, that's the same as b to the power of m plus n. So that's the product rule for exponents. This is the product rule for logarithms. So you can kind of see how similar they are. All right, so this is the product rule for exponents. Let's do the quotient rule for exponents, okay? The quotient rule for exponents is this. If I have, let's say, any base, all right, and I'm dividing it by the same base, what am I allowed to do to these exponents? I'm allowed to subtract them. So this is the quotient rule for exponents. So m minus n is the same as b to the power of m divided by b to the power of n. So that's the quotient rule. See how similar they are? There's the minus, there's the m, there's the n. Okay, and let's do the power property for exponents. So b to the power of m raised to the power of n is the same as saying b to the power of m times n. So this is the power property for exponents. So for example, if I had b squared and I raised it to the power of 5, that would be b to the power of 10, because 2 times 5 is 10. So those are the 3 rules right there that you need to be aware of. Let me go over here. So let's go back to where's our work? 1 second. Okay, right here. Let's look at the quotient rule. All right, so here we expanded. Here they are condensing. They're taking this and doing x cubed divided by y right here. X cubed divided by y. That's using the quotient rule. So let's do a couple of examples here. All right. So we have expanding and condensing. So if we're expanding, we're allowed to change this to log base b of b. And you're allowed to put a 4 right there. And we're going to put minus log base b. And we're going to put the letter c. So when you're dividing, you're allowed to subtract the logarithms right there. That's the quotient rule. See? Ta-da! Condense. So if we want to condense this, we're going to take this guy and put him underneath this guy. So we're going to say log, since there's no, basically this is a common log, even though you can't see it's a base 10. I'm going to open up a parentheses, make a fraction. I'm going to put the 3z on top. Oh, not 3x, sorry, 3z on top. And I'll put the 8 on the bottom. So this is how you condense it using the quotient property. All right? All right, so the power rule allows you to take this power and move it in front. So here they gave you a couple examples. They take something cubed and they bring it down in front. So see if we can condense. We can also condense by taking 4, putting it back up, and 2 to the power of 4 is 16. So that's what they did. They took the 4, moved it back up into the above the 2, so it's 2 to the power of 4, and condense that. So see if we can do this. Ready? So we're going to take this 5 and we're going to move it down in front. Take that 5 and move it down in front. So we'll put 5. And we'll put log base 7. And that's going to be x. So that's all I did. Take that power right there and move it down right there. That's it. And now we are going to condense this guy. So we're going to say this is ln, stands for the natural log. All right, so I'm going to put ln. We haven't talked about the natural log yet, but we will. We'll put the parentheses. I'm going to put y, but I got to raise that y to the power of 6. Just like that. That's all it is. Ooh, let's do a challenge problem. All right. How about this? We'll go ahead and we'll do this challenge problem, and we'll see how we do. Okay. So first thing I'm going to do is I'm going to use the quotient property. So I'm going to write log base b. I'm going to put that's 2x to the power of 3. So I'm going to put 2x to the power of 3 like that. I'm going to put minus log base b of 5. Then I'm going to use the power property. I'm going to move it down in front. I'm going to put 3 log. See here, 3 log base b of 2x minus log base b of 5. Let's see here. Then, hold on. You know what? I think I'm actually going to go back. Yeah, you know what? I'm going to go back. I'm not going to move the power property down just yet. Here, I'll go back. I just realized what I did wrong there. All right. Here we go. I didn't do anything wrong here, but I realized I couldn't apply the power property just yet. I got to do the product rule first. The product rule. So I'm going to put log base b of 2 plus log base b of x cubed minus log base b of 5. So I got to put that in parentheses. I got to put that in parentheses and that in parentheses. So this is going to be a lot better. Here's the final answer. Log base b of 2 plus, now I'm going to use the power property, move that down in front, which is 3 log base b of x minus log base b of 5. All right, here we go. Let's see if we find it. I like that. I like that. I think it's going to be, yeah, this one right. That one right there. I like that as the best answer. All right, got it. Okay. All right, so what we're going to do is we're going to take this one. This will be a good one, good example problem right now for you guys to do. What we're going to do is we're going to, first thing we do is we're going to move this up front. Okay, we're going to move this back up where it needs to. So this is going to be log base 2 of x cubed minus log base 2 of 5 squared. And then 5 squared is 25, so I'm going to write log base 2 of x cubed minus log base 2 of 25. We're going to use what's called the quotient property. We're going to condense this, all right? So log base 2 of, we're going to say x cubed over 25, and that will have everything condensed. So this is right here is the answer that I'm gonna choose. All right. Okay, so cool. So right now we're just going to start using some properties of logarithms, okay? So we'll be very, very, very easy, and we'll call it a day. So it says use the property of logarithms. This is the quotient property, and what's 15 divided by 3? It's 5, right? So I'm just going to put 5. Because this is the quotient property, so I can condense it. 15 divided by 3 is 5. All right, so we have log, so it says rewrite the following in form of log C. Well, what is 2 times 2? 2 times 2 is 4. Okay, so we're going to write it in log base C. So if I take this, I'll do this one by hand, so I won't just do it in my head. So this is, we've got to use the power property, got to move that back up here. So it's going to be log 4 cubed. Now 4 times 4 times 4 is 64. So it's going to be log of 64. So that's what I got to write in right here, log 64. And then once again we're dividing, because that says subtraction is the quotient property. We divide. 10 divided by 5 is 2. So this is going to be log, and we're just going to put open parentheses 2. That's it. Okay, so that's going to be pretty easy. I appreciated or enjoyed the article because it actually gives you understanding. Make sure you get all those in your table. So make sure, like I said, you get all of these properties right here in your table, because that's going to be super important for you to be able to do the work. And that's it. Hope you have a good day and get those done.